Hello everyone, welcome to this video. In this video, we'll be seeing this question which states that prove that a group with two elements of order 2 that commute must have a subgroup of order 4. Now, read the question carefully. Let us suppose and name all the elements and the things that is given to us. So here we are given a group. Let's call that to be G, right? And within this group G, they are saying we have two elements within it, right? It could have more elements as well, but let's take the two elements A and B, right? And what is given about these two elements? It is given that they have order 2 in G, right? And they commute with each other. So what does it mean? It means that A square is E and B square is E, right? If we assume the operation to be multiplication. And moreover, if they commute, then AB is equals to BA. Now we'll make use of all these properties here in order to show that it must have a subgroup of order 4. So let's call this subgroup as H, right? We are taking a subgroup H from this group G. Now we wanted to show that it contains at least 4 elements within it, right? So let's see what are those 4 elements we can have. So definitely for it to be a subgroup, the first element it should contain must be an identity element. Now what if it has an element A and an element B? What would be the third element? And is it required? Can we have some subgroup of order 3 as well for this particular group? So let's have a look. So here, because you see A square is E, from here you can very easily evaluate that the inverse of A is A only and the inverse of B is B only, right? So that means they are their own inverses, correct? So if H contains both A and B, so that means we are constructing a subgroup of order 3. Now let's see if that is the case, then what conditions do we have? So here you see E is the element here of this subgroup H. We are saying H is a subgroup. In that case, the inverse of each element should also be present here. So you can very clearly see the inverse of identity is identity, which is present here. Inverse of A is A, which is also present in H. And the inverse of B is B, which is also present in H, right? And moreover, by the subgroup test, if you take any two elements out of this, then A, B inverse should also be present here. So let's check whether this is present here or not. So if we now in this process, we are basically constructing our subgroup, right? So what would be A, B inverse? You know, B inverse is what? It is B. So that means A, B should also be present in H. So we have to enlarge our subgroup H by adding this particular element into it, right? So we now have 4 elements within it. Now let's see, is it complete? Do we require any other element or not? So here if you see, I can claim that this forms a subgroup. Why? Because it is closed, because if you multiply E with A or E with B or E with AB, it would be just A, B and AB, right? So they all are present in H. What about AB? A into B is already present here, right? A into AB, it would be A square B. A square is E, E into B, which is B. So B is also present here. Similarly, B into AB, B into AB, it is what? It is now, because it is commutative, so you can write it like this, BA. So you can write it like this, B square A. So it is E, B square is given to be E, E into A, which is A. And A is also present here. So it is closed, right? The next thing, it contains the inverse of each element. We already saw for E, A and B. What about this AB? Let's have a look. The inverse of AB is B inverse A inverse by the sock and shoe property, correct? Now inverse of B is B and the inverse of A is A. So therefore, because these two commute with each other, so you can write BA as AB. So you have the inverse of AB as AB only, right? So here in this case, it also belongs to H. So it contains the inverse of each element. Hence both the conditions are satisfied. Hence we can say this forms a subgroup and it contains 4 elements, right? We cannot have, so it is sure that under these conditions, there would be a subgroup which is having a order 4 within this group G, right? So I hope you understood this question well. Well, that is it for this video. Thank you for watching.